again, we are finishing the notes from last time, so this is regressions. Sorry about that. So again, we did the whole front page. We learned how to, by hand, write equations of lines. And today we're going to continue to focus on those calculator skills that we have that we used on the Chicago and Denver question. Okay, when we were trying to find the Denver equation, so we could talk about the slope, we used the calculator. Does anyone remember like the buttons we pressed? What was one of the names of the buttons that we pressed on the calculator? We did press alpha sometimes. What else? Stat. It's going to be called stat edit. I accidentally call it that all the time. It's called writing a regression. That's like the official name for it, but we're going to call it stat edit sometimes. So we're going to practice stat edit today, as well as add a little bit extra that might sound familiar from your Algebra 1 class, either if that was last year or 2 years ago, depending on what grade level you're in. But some of the vocabulary words that we need to talk about include the words line of best fit. A line of best fit, also called that regression, is just simply an equation that best goes through all the points, or a line that goes through the most points. Okay. Now, any set of data, if one thing is related to another, we can find a correlation. We can figure out how closely related they are, but we don't know how good that data is until we see the line of best fit and we talk about the correlation coefficient. Correlation coefficient should look familiar to you. In Desmos, it was one of the things that popped up when we did y1 squiggly line mx1 plus b. There was this letter r that was some number from -1 to 1 that measures the strength and direction of the correlation. It's when we give the correlation two adjectives, strong or negative, strong or weak, positive or negative. We're back to doing that again, but we're going to do it with the calculators this time. Now this idea is not new. Again, if you have a strong negative correlation, that means that you have the data points really, really close together and it's going downhill. If you have a strong positive correlation, that means the data points are really, really close together, but the line is going up. Anything else, when the data is weak or there's not really a good what's called trend line or line of best fit, something that maybe looks like this, it's flat, we can call that no correlation or a weak correlation. Now, determining whether something is strong or weak is going to come from the number that we get for this R value. So we're going to get these numbers R out of our calculator to decide if it's strong or weak, positive or negative. The cutoff for it to be considered strong, we're going to use 0.7. If it's 0.70 or higher, so 0.70, 0.80, 0.90, or 1, it's going to be called strong. If it's negative 0.70 or lower, or negative 0.70 or higher, however you think about that, it's going to be considered a strong negative. So basically, if it is a passing grade, if it was a percentage and it is a passing grade on a test or an assignment, you're going to consider it strong. Anything else in between negative 70 and positive 70 is going to be our weak correlations. So 0.1, weak. Negative 0.3, weak. Things that would not be good grades necessarily, passing grades, 70 or higher, we're going to consider weak. If you ever take a statistics class in college, you can change your, it's called a p-value for what you determine as strong or weak, but for us, we're going to use 0.70. Okay, so good grade on a test is strong, bad grade on a test is weak. Does that make sense to everybody? Okay. Ooh, we're done writing on the spiral page. The last little piece of info here is exactly what I just said. The closer the value of r, not r squared, notice it's just r, the closest that r value is to 1 or negative 1, the stronger the linear association. So you would say, yes, it's a line. The closer the r value is to 0, the weaker the linear association. And you'd say, oh, it doesn't really use a line. It's not a good prediction. So we want them to be strong. Now the reason that we look at this sort of stuff, you know how on the internet you can pretty much find a graph that represents like anything? Like, right? The internet has some weird graphs on it. You have to also determine if those are actual good correlations. And this is one of the ways that we do that in statistics, to see if the inputs actually make the outputs happen. Kind of like the cause and effect relationship you learned about before. It's just another way to look at data. We're going to do this example together, the first one. You're going to have the second one to do on your own. Now, I'm going to do a lot of calculator pressing, so you're going to have to follow along with me. But you already have these buttons from last time. It's going to be the same steps in the handout that we used last time to write a linear regression for this data. The thing is, last time when we did it, we had a table of values. Do I have a table of values for this first example? No, what am I given? Points on a graph. I would like a table because it makes it very easy to type it into the L1, L2 on my calculator. So what we're going to do is we're going to take all of these points and we're going to put them into a table. So let's first read this graph so that we can make our table. All right, this coordinate point that I just highlighted green, what is the coordinates for it? 1, 5. Now here's the thing, there's no 1s, there's no 5s actually listed on my axi, which means if that's going to trick you up, I need you to go ahead and fill in all of the numbers so that you make sure you know what those numbers are. If you don't need that, you don't need that, but it might be helpful for you to have all of those numbers written on your page. Yeah, so always check your axis to make sure you know what you're counting by on your graph. Fabulous. This next coordinate that I highlighted, what is the coordinate for that? 2, 2. So we went to the x-axis of 2 and the y-axis of 2 for that coordinate. Do we see how we're getting these coordinates? It's maybe been a minute since we did x, y's. We can do that for all of the rest of these data points, getting that the next one is 3, 1, and then we have 5, 2, and we have 5, 5. Those coordinates can go in a table so that I can type them in. We just need to make sure that we keep the right x partnered with the correct y. Don't mix and match them. They have to be partnered up with exactly what they were partnered with on the graph. So I've just taken the coordinates and I put them in a table so that it looks exactly like the Denver question we did last time. At this point, I'm going to jump over to my calculator and go back through these steps with you before we come back to the notes. If you are like, when I go home, I'm going to need to re-see the calculator steps. There is already a video on YouTube of how to walk through these steps on the calculator. I did it slowly so you can kind of see how this is done, okay? So what we've got on our screen at this point of our calculator is all of the values that we're going to need to write our equation. You see that it gives you a pattern at the very top that you want to fill in numbers. We want to fill in an A and a B. Normally it's M and B, but the calculator calls it A. And we want to put these numbers here. But we're going to have to round these numbers because we're not putting all that. No, thank you. Different questions will ask you to round different ways. For our notes, we're going to round to the nearest hundredth, which is 2 decimals. There's a rhyme that y'all learned in elementary school about rounding. Yes, 5 or more, raise the score. 4 or less, let it rest. So if I want to save 2 decimals, I'm looking at the 7. Does this 8 behind it make it round up to 8 or stay at 7? Do I raise the score? Yeah, because this 8 is going to tell it to raise the score. So this is actually going to be negative 0.08. There's 2 decimals in B, so I don't have to round anything. So my equation, when I look back at my notes that I'm writing here, for this data, for its line of best fit, is y equals to negative 0.08x plus 3.25. Is that correct? I just did those numbers off my memory. Yes. That's the equation. I just took the numbers, put them in the equation. We did this last class. What we didn't do last class was talk about the correlation coefficient. Look back at your notes for a second. It's basically the top of this page. What letter did we say we were going to use for correlation coefficient? R. Isn't there an R showing up on your screen of your calculator? Yeah, we're still going to round that one to 2 decimals. So we're going to look at this 7. Behind it is a 4. Does that 4 let it rest at 7 or raise it to 8? Let it rest. So my R value is negative 0.07. That's what I would write down for my correlation coefficient, negative 0.07. All that we have to do now is give it two adjectives. First adjective is real easy. Is it positive or negative?
Negative.
Negative. That's the first adjective that we can answer because we know that that number is a negative number. Now, if this number were a percent, aka a grade, we'd move that decimal twice, is a 7% a good grade you should get on a test? 7. Should you get a 7 on a test? Please don't get a 7 on a test. This is a weak correlation because they don't even actually look like they're in a line. Do those dots look like they're in a line? So we should get a weak correlation. They're not really close together in a line. Again, it's weak because the number that we would get if that were a grade is not bigger than 70. It's 7. You don't get that grade on a test. Okay, the second example on this page, you're going to do with your group because I need to make sure you can do it without me like putting the training wheels on for this. Okay, we're still going to be walking around and helping you, and you have 4 brains or 2 brains at your tables working on the problem. Start at the beginning. I want you to do the whole thing yourselves. So here's the table of values we should have written from reading the graph. And we're going to go to the calculator and walk through our steps together. I'll say them out loud on the recording. We're going to go back to the quit screen so that we can see blank. And everything's already turned on, so we don't have to turn anything on. Okay, so we go to stat, we go to edit. Now you do already have stuff in your L1, L2. There's a bunch of options for what you can do about this. Number 1, you could just start typing over them. 0, enter, look, it replaces it. 1, enter, 2, enter, 3, enter, 4, enter. You can clear the entire list by going up to L2 and pressing clear. Don't press delete because it gets rid of the list. Or ignore going to L1, L2 at all since you don't want to mess it up. And just press delete on all the numbers, and it gets rid of your numbers. I just like overwriting the table because it just types over them. But you can do what you want. This is 25, 20, 15, 10, and 5. Once I have all of the coordinates matching up, I press stat. I go over to calculate. I choose option 4. Scroll down to store regression equation. Send it to Y1 by pressing alpha trace enter. And then going to calculate. So the formula that I get for this equation is y equal to negative 5x plus 25, which makes sense because my y-intercept is 25, and I have a slope of negative 5. We went down 5 over 1 every single time. But we didn't have to do any of that by hand. We let the technology do it for us. The correlation coefficient is what? Negative 1. Remember, R is correlation coefficient. You will not use R squared until you take advanced statistics. You will only use R in this class. So the R value is equal to negative 1. Let's give it 2 adjectives. First of all, is it positive or negative? Negative. So for sure it's going to have the adjective of being negative. The number is negative, and the slope is negative of that line. Yes, ma'am. Mm-hmm. Now, is that strong or weak? Strong. Because if I were to make this a percentage, right, that means decimals here, and I move that decimal 2 times, that would be a 100 on a test. That's a good grade on a test. So that's a strong although negative, correlation. This would be a good representation of a line since it's very, very strong. So if it's weak, it's not a good line. If it's strong, it's a good line. Okay, questions before we move on to our last example for the day? And hang on with me because I'm going to show you something really cool in the calculator. You'll have to write down the steps because it's not listed anywhere. So hang on with me. This last example talks about the table of humerus lengths and heights of several females. So at this point, we're scientists, we're measuring stuff. First of all, does anyone know what the humerus is? It is a body part. Do you know what body part it is? You know when you like hit your funny bone, what are you hitting? You hit your elbow. This part of your arm is called the humerus bone, which is why they call it a funny bone, because humerus means funny. So that's your humerus. They measured a bunch of humerus, which is that bone right there in your arm, and they measured how tall the females are just to make this data. We're going to try to write a regression equation to start predicting the future. So if we measure somebody's humerus length, we maybe figure out how tall they are, since those two things can be related together. So we're going to do part A on our calculator, use the linear regression feature on a graphing calculator to find an equation for the line of best fit for the data. Here's the thing. That's a lot of numbers. You have to include all of them. All of your data needs to go into your calculator. So let's start typing because it's going to take us a minute to put all those numbers into our stat edit. So let's get started. So getting these numbers and rounding this time to the nearest tenth, we're going to get that the line of best fit is y equal to 3.1x plus 63.5. Here, I'll show you now. That's the equation we should write. I just took the numbers out of the calculator and popped them into the equation. We also want to decide how good this data is. We want to know the correlation coefficient. We're going to always round the correlation coefficient to 2 decimals, so 100. That means we save 2, so we look behind it. Does this 4 make me change this 8 to a 9 or leave it as an 8? 8. Leave it as an 8. Fabulous. All right, so my correlation coefficient is r equal to 0.98. We want to interpret that, so we give it 2 adjectives. What are the adjectives that I would give that? Positive for sure. What else? Strong. A 98 is a really good grade on a test, so that's going to be a strong positive correlation. That means it's a good set of data, that your humerus length does affect your height. So the part C that says, does this data show a linear relationship? That would be a yes. And only because that this is strong. If it was weak, we'd say no. But since it's a strong correlation coefficient, we say yes, it shows a good linear relationship. Now part D is wild. We're going to write some steps down on your piece of paper because these are not on your calculator steps. It says estimate the height of a female whose humerus is 40 centimeters long. Question. They gave me that the humerus length is 40 centimeters long. Did they give me an input or an output? An X value or a Y value? Ooh, read the table. An X value. So they're saying that X is equal to 40. When you did this kind of problem in Desmos, you would have typed X equal to 40 on the screen. It would have graphed a straight up and down line at 40, and you would have just found where the two lines cross. Calculators do not work that way. You cannot graph vertical lines on these calculators. So we have to do something different. The reason that we press that alpha trace enter is because all of these numbers from my calculator screen, do you see them, all those numbers, are already put in my Y1. If you press Y equals up here on the top of the screen, those numbers are already in your calculator. I didn't have to type them, it just sends it to them. That's nice, we like that, okay? Which means we can find a graph when we press graph, just like we would have on Desmos. Everybody press graph right now. The thing is, I don't actually see a graph. In Desmos, you would have zoomed out. Okay, this doesn't have the same sort of zoom feature. You actually have to press the word zoom Do you see the word zoom? And if you want to zoom out, what option is that one? 3. So we're going to go to option 3, and we're going to press enter to start zooming out. And I want to see a lot of the graphs, so I pressed zoom out twice. That would be like pressing the little minus button on Desmos to zoom out, or the plus, whichever one zooms out. Okay, so now that we see the information, we want to basically figure out what the value would be when the input is x equal to 40. So what we do is the following, and I'm going to have you guys write this part down. Once we have it graphed and zoomed correctly, sometimes you don't have to zoom. So I'm just going to press graphed and zoomed. That's the first step. The second step is that you're going to press second, trace, and you're going to choose option 1 that says value. When I do that on my calculator, press the blue button for second, you press the trace button that we've been using, and you choose option 1. Here's what comes up on your screen. Second, trace, 1. It's sitting here and flashing and asking you, what does x equal? Well, guys, what does x equal in this problem? 40. So we type in 40 and we say go, we say enter, and your calculator is going to figure out what the output is, or the value is of the graph, when the x value is 40. So my calculator is telling me that when x is equal to 40, that y is equal to 185.6. That's like a coordinate, 40, 185.6. So we're saying that the output is 185.6, meaning if the humerus is 40 centimeters long, that person is probably 185.6 centimeters tall. This is the same thing you did on Desmos, just with the steps for the calculator. Again, you have to make sure you're zoomed out so you can see the graph, and then you can do the value. It's just different steps.